Okay, so today we're going to have a look at a rotation about the y-axis. So, similar to what we've done above when we rotate about the x-axis, except we're going to be rotating along the y-axis. Now, I'm not going to prove the formula again, it's exactly the same, except instead of squaring y, we're squaring x, and we've now got dy. Now, importantly with these questions is that if our bounds are given as x points, we need to find their corresponding y points because we're integrating with respect to y, not x anymore. Also, we need to find x squared, so sometimes we might need to make x a subject of our equation. So here we're finding the volume of the solid formed if the region between y is x squared and y is 4 is rotated about the y-axis. Again, let's draw a picture. Y is equal to x squared, and we're rotating about the y-axis from 0 to 4. So it's going to be like a funny bowl-looking thing. So again, we need to make x the subject of this equation. So we can see x is going to be the square root of y. And our formula is volume is equal to pi times by x squared, which is root y squared, which is y, dy. And we're integrating from 0 all the way up to 4. So 0 to 4. So volume is pi times y squared on 2 from 0 to 4, which is, what's that, 16 on 2, which is 8 pi. So the volume of that solid is 8 pi. Again, I think it's quite fascinating that something as so obscure as a bowl can have a volume that's so exact, and it's 8 pi. I don't know, I think that's quite fascinating. The volume of the solid formed when y is 2x is rotated about the y-axis from x is 0 to x is 3. So here we've got y is 2x, and we're rotating from x is 0 to x is 3, but we're rotating about the y-axis, so we want this funny shape here. So we need to find the corresponding y-coordinate. So if y is 2x, then this is going to be 6 up here. So really we're going volume is equal to the integral from 0 to 6. Now x is y on 2. So x squared would be y squared on 4 dy. So the volume is equal to y cubed on 4 times 3 is 12 from 0 to 6. Let me just, I feel like I've done something wrong there. Let me just check. That's what I got before. Yeah, that's what I got. We'll put a pi out here from 0 to 6. So we've got 6 to the power of 3 on 12, which I think is 18. Yep. Now something cool we might want to see, this is a cone with radius 3 and height 6. So volume is 1/3 pi r squared h. So that's going to be 1/3 times pi times 3 squared is 9 times by the height of 6, which is actually 18 pi. You've got to find the volume of the solid when the region bounded by x is y squared plus 1, 0, y is 0, y is 1, and x is 0 is rotated about the y-axis. So we've got this region here is rotated around, so we put this up to here. We've got like a funny, looking like it's like those yo-yo thing shapes. Yeah, so we do form some funny looking shapes here, but they can be quite useful, especially something like that, when it forms a cone. So really, we're looking at volume being the integral from 0 to 1, because we've got 1 up here, of y squared plus 1 squared. And again, we're good. We don't have to make x a subject because it's already the subject, dy, which is the integral from 0 to 1 of y to the power of 4 plus 2y squared plus 1 dy, which is, forgetting to times it by pi times by y to the power of 5 on 5 plus 2 on 3 y cubed plus y from 0 to 1, which is 28 on 15 pi if you substitute all of that in. And that's rotating about the y-axis. Thank you.